By my count, it is 1 p.m. and we're going to go ahead and officially start. So today's webinar is all about safety, because when you're talking about high voltage and EVs, I mean, safety has to be first and foremost in everyone's minds. So we're here to be your experts and advise you on some of the PPE items that are out there and safety protocols. So joining us and leading this will be our Director of Education, Nathan Banky, and our electric vehicle expert, all things EV, Mr. Dave Giles. Go ahead and take it away. FYI, if you have any questions, the chat is closed, but the Q&A is open. So go ahead and put any questions you might have in the Q&A. And at the end of this, we'll kick back to them and answer your questions. So go ahead and take it away, guys.
Okay, great. Well, thank you everyone for joining us today. I'm Dave Giles, and joining me is, like Jimmy said, is Nathan. And today we're going to be covering one of probably several different series in talking with EV safety. And in developing this and putting this together, it's amazing how much there is involved with the process and preparation of safety, for your students and yourself and dealing with EVs. And a lot of systems are redundant systems within the vehicle. We're going to look at a couple of them today, as well as we have some, we're going to talk a little bit about the PPE today. We're going to talk specifically about the gloves, some of the aspects of the gloves that you may or may not know of. And also I had just showing some of the other stuff I have here, talking about arc flash protection. Probably do that with another module when we're dealing with the battery. So we're actually going to do a little segment, not today, but another module on batteries. Some of the protection devices, some of the components within a battery, high voltage battery. And that's when we start getting to using some of the specialized PPE, like your arc flash protection. What level do you need? What types of components? And how do you prep your area as well when dealing with open voltages, such as inside a battery case, and then reassembling and testing that case as well. But today we're going to be looking at a couple of different aspects with the safety side of it. And we're going to be looking at specifically in the isolation side. That's a big topic. Everyone talks about these, installation testers, what that process is, how does the vehicle monitor it, as well as we're going to look at some of the interlock circuits. And at the end of it, I know in the last session we talked about using the CL 1919, the Ohm's Law trainer, and creating a circuit for that. And Nathan will talk a little bit about that and how you can use in 1919 and create an interlock circuit. And do you have something to say, Nathan?
Yeah, I was just going to say, to add what to Dave was saying, is that what's always fascinating for me is that looking at any vehicles that have high voltage systems, hybrids, hydrogen-powered, battery electric vehicles, anything with high voltage, it's always very fascinating to me to see that numerous layers of protection and how they stack up, whether it's the insulation measuring, whether it's the isolation of the entire DC high voltage system from the low voltage system, to the interlock circuits, to all these systems that are there to protect the technician. So it's really fascinating to me to see that at numerous levels, all of these systems that have been put in place by the manufacturers, by the engineers, to keep it safe for the technicians. You'd have to work really hard on most vehicles. You have to work really hard to hurt yourself. There's so many protections in place. So very fascinating.
And that's very true. It's one of the comments we make. You actually have to know what you're doing to hurt yourself, and it's because of redundancy within the safety system. But that doesn't dismiss the fact that you have to respect the high voltage, and some of that respect comes from the PPE that you're going to wear, as well as the process that you're going to follow while doing that high voltage work. So that's really important part of all about EVs is, making sure you're safe, making sure you're following the processes, and understanding what you're testing and what you're looking for in that testing. I'm actually going to cover a little bit today, and I wanted to bring this up and like one of the things that we were talking about earlier is, when we start arranging these, I could have gone through the gloves, the glasses, the arc flash protection, and some of those, the different voltages and and some of the things that can, where the limits are. And there's so much of it out there right now. I just wanted to jump right into other aspects of the EV safety and incorporate both into the PPE and the vehicle itself. And these are great ways to get you introduced into why PPE is necessary and when to use the different types of PPE and also how to use that PPE. So we'll move on.
While you're moving on there, I'll just say one thing is that I really would like it for the attendees today, if you have feedback, if there are other areas you'd like us to investigate further, please let us know. We asked in the last couple webinars to have some feedback. We got very little, so we assume that you like everything and that it's going great, but it would also be, hey, we'd like to hear more about this, or we really like that. So please give us some feedback if you have the chance, and that'll help guide us in our subjects and the way that we approach them for you in the future webinars. So
yes, that's great, Nathan. Thanks. Yeah, that's important for us. This way, we're like a wealth of knowledge and information, and we love to share that information, but we need to know what you might be looking for. Even if you say, hey, I want to learn more about how to use an installation tester, or I want to know more about the high voltage safety gloves, or even some of the other aspects of what a DC to DC does and so on. We'll be more than willing to share that type of information. Okay, great. So I'm going to start off with obviously the biggest thing with electric vehicles, or even any kind of high voltage electric use, is the gloves. These are typically linesman's gloves. They're not EV gloves. Were designed for high voltage work from various different levels of electrical, installers, electricians, contractors, and so on. And we've adopted them into the EV field because they're proven, they work. But there is some limitations with these gloves, and this is some of the things that we need to be recognize when we're doing this type of work with these gloves. So one of the things, first of all, is a Class 0 glove is really the basis of it. Even though I get asked before, I say, well, how, Toyota's like only 200, just around 200 volts. And why do I need a Class 0 glove when working only on 200 volt systems? And then you can talk about capacitance and, discharge and stuff like that, where the voltages can ramp up. But most times that's in a operational mode, not so much in a stationary mode when you're touching the high voltage system. So, there is some gloves out there. I think I have a pair here. They're actually Class 00. If you can see that, I have Class 00, and this is actually a 500 volt pair of gloves. And then I have my Class 0 gloves as well here. These are up to 1,000 volts. And even though we talk about the different voltages, if you are planning on buying PPE and supplying it for your students, I always recommend going with the Class 0 because it covers everything. And even if you're working on lower voltage systems, the 200 to 300 volts, some of the nickel metal hydride batteries, maybe you just have a couple hybrids here that are doing, it's still better to go with the Class 0 gloves. It covers, all the voltage up to there. And of course, we have new vehicles coming out, the Porsche Taycan, that's 800 volts. And they, obviously the Class 0 gloves would be recommended for that. As well as there's two different types of gloves too. A lot of people just say, yeah, I just need a pair of Class 0 gloves. I need a size 9 based on my hand for measuring, but sometimes not realizing there is different types of Class 0 gloves. There's different types of Class 00 gloves. There's different types of Class 1 gloves. So, so these are, the different types do matter depending on the type of work you're doing, where you're doing it, and, and some of the areas you're doing it in. So, and because one of the things with the gloves, it's important to recognize that these gloves are about protecting as a primary protection against high voltage when handling, high voltage components.
For a typical school, we would recommend then, if they're going to be purchasing gloves, is to have a class 0 sized, obviously per user. So for the instructor having their own set, and then a lot of schools, they're going to have variances. Are the students buying them? Is the school supplying them? So there's that to address, but that would be the suggestion, because like you say, then you could work on a Tesla Cybertruck, or you could work on an old 20-year-old Prius, and you're going to be fine on both of them, right?
That's right.
So.
And you want gloves that are malleable, that you can work with. And that's the other thing. Like, they have to be able to have a certain amount of flexibility when we're working on vehicles. Now, mind you, if you're a linesman working on 50,000 volts, that flexibility might not be as much required. But when you're working on circuits where you might be disconnecting a pyro fuse that's used running like a 10 millimeter bolt, running with a set of gloves that are very thick and protected, and maybe very, very, and that, in fact, it could actually cause, it could be a safety concern too, because you might not be able to grab those components properly.
So Dave, what's the difference between the Type 1 and the Type 2?
Great question. Okay, so we're going to get into that. One thing I can move on. Let's do that. That's a great idea. So one thing about the protective glove classification is not the color of the gloves, because once again, we have different color gloves out there, and sometimes people relate that color to the classification. Each classification actually is colored. So 0 gloves will have the tag being this reddish color. The ones I had there were that beige color of the double O's, and so on. So depending on what level of voltage, make sure the tags are correct. Now, going into that Type 1, Type 2, Type 1 are the non-ozone resistance gloves. And Type 2 are ozone resistance. And ozone is created from high voltage current through circuits, and creates this ozone, which can actually break down rubber very quickly. In electric vehicles, it might not be as much of a concern, but the potential is still there. So that's why we have to test the gloves every time after use, do the air leak test on them and have them recertified every 6 months. But I put in here, I just say, as well as UV. So if you're doing a lot of work outside, you have the students doing different things outside, but the gloves are going to leave them on the fender of the vehicle. They might be working in direct sunlight, depending on what they're doing, especially in the southern U.S. states. Then definitely you have to be aware that the gloves are also, in a Type 1, are also non-UV protected. That means also ultraviolet radiation, just not ozone from high voltage, sensing.
From the arcs.
From the arcs, and just from the current flowing creates ozone. But the thing is that the UV light can also cause some damage. And I think that's more the concern, because ozone is usually created within a confined area with high voltage current flowing. I always sometimes refer to, you can smell ozone sometimes in electrical circuits. It's not true, but there is that, when you open a panel box that's carrying like 600, 400 amps, 600 volts, 400 amps, and you get that electrical smell almost coming from it. They say that's the ozone, but anyways, by being with automotive, having the gloves outside, in the sunlight can cause some damage. So, and the ozone resistant gloves, somebody said, well, why don't we just buy ozone resistant gloves? Well, these are those gloves I was talking about. They're very thick, they're hard to move, they're not very malleable, and they're just not very functional for that type of work that we're doing on EVs. So just be aware of that when you're purchasing your gloves. It does indicate right on the glove the type of glove it is, well as the class of the glove. And if you're not sure, it will tell you the voltage range of that glove. So once again, it gives you some sort of assurance that you have the right ones. Now, the other thing, people will say, well, I just bought a pair of gloves and they're in the box. We opened them up, but they're already expired. And in fact, most of the suppliers for the gloves and so on, they say they're good from the first year of date, and most of these boxes will have date stamps on them for when they were put into service. This one here actually has a date stamp on the end of it, or they wrote it on there. So it's good from 1 year from that date, and then every 6 months after that, they need to be recertified. And the recertification is not the same as doing your test. Doing the blow test. They do a lot of different things to the gloves. They stress them. They also check the sleeves and so on. There's a bit of a process to be done with it. So it's not just, taking the gloves and doing, doing the seal test where you fold them over and then roll them, and then you kind of just take them into a point where you can get them, and then you listen for a leak in the glove. Because when you do that, you're actually not testing the sleeve part of the glove. So, and they actually do a bunch of different other tests to the gloves to ensure their integrity as well.
Yeah, this is also an excellent, all of the questions relating to the gloves, the expiration, the types of gloves, the level of voltage, the ozone and UV protection, all that is a great student activity to have and do with your students. We've been writing student activities, student assignments for various Constellat products here in the last couple of weeks. And that's something that, again, we would suggest to anyone teaching this. If you're not already doing so, that's a great thing to start with your students, is to have them go through all that with the gloves, grab a pair of gloves, fill out the information. What type is it? What voltage is it approved for? When does it expire? How would you test it? You're probably already doing this in your schools. Most of the schools that are teaching this, but there are some that are just getting into it, and this is newest to them, but that's what you got to do.
Yeah, and one other thing on the storage of gloves, one thing you'll have students, they'll take the gloves, they throw them in the toolbox, or they leave them on the tables and that. There's actually a procedure for storage of the gloves, and one is removing the leather from the gloves themselves, so make sure they're separated, make sure they're dry and clean when they go in, and they go into the bag. Actually, you drop them straight into the bag itself, and make sure you put them back in the bag they come with. There is some components out there, as well as the leather gloves can actually go in the bag as well too. I prefer not to put the leather gloves in the bag. I like to just put the leather or keep the leather gloves separate in the box of the packaging. I just roll up the bag itself. I put it back in its box, and then I lay the gloves on top of it and then lock the box back up. So this way, once again, they're out of the way, they're stored because they're a very important piece of protection. It's just no different than safety glasses. You got your safety glasses and you're throwing them around and they get all dirty and you're wiping them off. And, you want to take care of the PPE because, like I said, if something fails because you weren't aware of it, you didn't store them properly, you could wind up, creating a problem, especially if you're not doing the testing before that either. So testing every time you go to use them, certifications every 6 months, and 1 year from the original date of manufacture on the actual packaging itself, so these gloves can be used. So anyways, any comments there, Nathan, or let's move on? Good. Okay, great. So we're going to move on to EV safety systems. I broke this down. Actually, I have a little different slide. But anyways, these are some of the things that we talk about in EV safety. There's many things, and I could go into pages of different things, from setup shop equipment, from your glasses to your arc flash protection if required, some of your special tooling, your insulated tools, your meters, scan tools, and so on. But I just want to really squish it down a little bit into some of the high voltage stuff, high voltage insulation, high voltage battery cell level protection, which we're going to cover in another module, looking at some of the different test points with high voltage. But today we're going to be looking at definitely the high voltage interlocks and high voltage insulation. I got that twice on there, so definitely that would fill the pages a lot quicker if I'm duplicating stuff. And also, I want to do a session as well too, and this is once again from feedback from you guys. But first responders loops, what do they actually do? Do they interfere? Do they interject with the interlock circuit, or are they separate? How do they affect the airbag system? Are they part of the airbag system, and so on? And what they actually do to the vehicle. And that's actually the scary part that a lot of people don't realize, is sometimes these first responders interlock loops don't do what they think they're doing. And so we want to make sure that's clear. But today we're going to be covering the interlocks and isolation. We're going to go through that quickly. This way we can make sure you have some time for some questions here. So the high voltage insulation is part of the vehicle's, way of keeping the system integrated and integral with the chassis of the vehicle. So make sure it stays isolated. And this is a big part of what a lot of people don't understand, is that the high voltage system has nothing to do with the chassis of the vehicle. It is a separate system. It's basically a floating power supply in the vehicle, just like taking a cordless drill and putting it in the trunk of your car. I can go to the cordless drill, pull that cordless drill. It has nothing to do with the chassis of the vehicle, but it will operate, has its own power supply, and so on. So very similar to that. So the high voltage system is separate from that, which means that if something happens within the system, there's a short to ground from the high voltage terminals and so on. There's so many systems in place to do that. So I kind of actually did that. So what I have is basically I have a 371 volt with one of our Tesla iDevs that we have here at ConsiLab. And essentially, I put a jumper wire directly from the high voltage positive contactor to ground. So I put a jumper cable to ground. But before I did that, I wanted to measure the voltage. So you see here on my picture, I don't know if you see my mouse, but I'm reading 371.19 volts. And then I didn't put the jumper on it, but what I did is I put it to the chassis of the vehicle. Actually, in this case, I put it to the case of the charger, the PCS, the power conversion system, and I got 173 volts. And it's like, whoa, okay, we got 173 volts, but you just told us that there's no power, no relationship to the chassis, but now why are we getting that voltage? So it doesn't matter if I measure here, over here, I'm still getting this very residual voltage, I guess they'd call it, is very, very. So what I do is I put a jumper wire. So what I've done is, well, first of all, I went to the screen to show the isolation, how it looks at it for both internal and external. And then what I did is I put that jumper wire. I put a jumper wire directly on the positive terminal and put it to ground. And then I turned the vehicle on. And the question would be, this is a positive contactor, and it's directly going to ground on the vehicle. And I got many amps. I got much pressure with voltage. And guess what?
Yeah, the question is always, are you going to let the smoke out? And of course, the answer is no. None of the smoke came out.
No, none of the smoke came out. So, in fact, the vehicle does detect the isolation fault. On the vehicle, it will run a series of checks, even though once it notices the isolation, to determine is it internal or external of the vehicle. It does that on the screen, so you can see that the bonus is it will tell me whether it's inside the battery or it's external of the battery. So it told me that it was external. But the cool thing was I left the contactor, turned the contactor on, then measured from the positive terminal again to that chassis ground. Now I have 0 volts, and I'm grounded, and the vehicle is still powering. It's still powered up. It's still operating. As you can see, it's right now I'm still checking internal resistance, but the system is still fully functional. So that floating ghost voltage is something that we have to be aware of as well too. So high pots and stuff like that are used to eliminate these types of voltages that are kind of within the circuits, but also at the same time we want to make sure that it's safe. So that's something we just noticed, like when I was doing the test, I thought it would be interesting for if you were trying to whoa, hang on a second, I thought there's no voltage here. I disconnect the pyro fuse, I disconnect the service disconnect from the vehicle, and I'm measuring, and I've got voltage to chassis. Why is that? So, but once again, it's elimination. What was really cool though is that how it identifies where my fault was in that system based on the resistors that are put in play for the high voltage system and how it's actually being monitored. Yeah. So in this case here, I'm just running a self check, but at this point I had put I'd removed the fault within the system, so now it's running a self check to return itself back to normal operating.
Just for the uninitiated, those who are not extremely familiar with working on Teslas, in order to do this, you need to get into the special service mode of the Tesla. So don't expect to just walk out to the car and throw a jumper wire and see you're going to get this. The driver, the customer or the person who's driving down the road with their Tesla doesn't have access to these features. You need to be in the service mode in the Tesla touchscreen of a car.
Yeah. And if it's something you guys want to see and how to do that, we definitely would love to do a little video on accessing service mode in Tesla and some of the features and functions of service mode. Okay, so let's going to move on here. Loss of isolation, LOI is what we call it. Installation tester is very important. This is how they do it. Couple different things. I don't want to spend a lot of time with this. I know we can cover this in another topic. I just want to go get you guys, kind of freshened up with it. But the installation tester, I'm using a Fluke 1587. It does apply voltage. It's no current, but very high voltage. It can go up to 1,000 volts applied. Typically, you want 2 times of what the voltage that you're testing. So if it's a 300, 400 volt system, you want to go up to about 1,000 volts. If it's a 200 volt system, you can go 500. Lots of really cool things you can do with this. But one thing I want to do is talk about safety. I'm not teaching about installation testing right now. Safety with these meters, very important. I can turn this right to 1,000 volts. I'm going to turn my little screen on here. I am going to actually, I'm going to hook up my leads real quick. And I'm going to do the installation test. One thing about doing installation tests is that you always should test your equipment. So right now I got 2.2 gig ohms. I have an open circuit. I'm going to test my equipment right now. I'm going to take that. I got it jumpered across. Now I'm going to redo this test here again. And now I got down to 0. So it should be down to 0. Let's see here. Oh, it's not 0. No, what's going on? So
I don't know.
So one thing that happens with these here is when you're doing your installation test with your meter is that you got to make sure, I don't have the actual lead here, but one thing is make sure that in the meter itself is that you have, get this opened here, I had it opened, is there's actually a battery inside here that actually, or not battery, a fuse, sorry, that I'm trying to open this up here. And this fuse is actually part of the high voltage function of the meter. And if you don't test it before using it, then what happens is that you can wind up getting false readings, just as I did. So I can still keep doing this test until I actually
getting 2.2.
I'm going to keep getting 2.2 on this test because of the blown fuse. So it's very important to make sure you double check your meter when you're doing your testing. So when I'm testing the meter now, I'm going to do it again. I'm going to put the small fuse, which is in the back of the meter. I'll put it in and I'm going to rerun the test here. I'm going to turn the light back on and it should come up with
0.0.
0.0. But if I remove that fuse,
you're going to get back to 2.2.
Again, so very, very important if you're testing, you don't want to get sidelined. And the question is, how do I blow that 1,000 volt fuse in my meter? And I'll tell you how they do it. Just like you blow a fuse in the meter that you're doing current testing on, you forget to change the leads over, you take your meter leads, and then you test the DC voltage of a battery, and it will pop that fuse, and there is absolutely no indicator. Right now the fuse is still out of the meter, and the meter will still function totally normal with no indication that the fuse is gone. So very important, double check your equipment anytime you're using, especially installation testers. The other quick point I want to make as well is when you're doing the test, it's a stress test. You're pressurizing the system, no different than you're doing pipe testing on a house. Plumber comes in, they put all plumbing in. If you're running 42 psi, they're going to jack it up to like 60 psi or whatever to ensure that there's no leaks or stressing that system. That's what installation tester does. Don't just push the button for 1 second and check for installation. Push and hold it. and a minimum of at least 5 seconds. In some cases, it can be a lot longer depending on what you're testing. So it's important to make sure the batteries are also very good in the meter itself as well. So always check your meter, make sure that it's working properly. And,
Yep.
And like I said, it's always, we talk about live testing and so on in other modules, but we'll definitely, check your equipment. You want to add anything, Nathan, there?
No, I was just going to say the one thing is how do they blow the fuse in the meter? And I was going to say the one thing that happens is when you hand the meter to the student, pretty much immediately, fuse is blown.
Yeah, what they do is they don't move the meter leads
to the right side
over,
and
then when you don't do that, then you wind up you have. And also, if you're doing installation testing, make sure you move your leads into their proper locations too.
Yeah.
It does show a join between the two, but make sure that you put the leads in the right location. And there's another lead that goes in there as well.
So I see Jimmy's jumped on here. We've gone right to the half-hour mark.
Oh, gee, okay.
So time flies when we're having fun. So Dave, we will come back to the other. We will come back to the other content, I guess, in the next month's webinar. But we'll go to the Q&A now and then finish this up.
Yeah, there's a good comment from my friend Tony Martin, all the way out in Alaska. He said, I was going to suggest that instructors keep some gloves that have failed for students to see what a bad one looks like.
Totally.
Absolutely.
Or leave a pair outside. If you get an extra pair that's old, and then put it outside for a day or two and let the UV kind of chew, like, make it more brittle, and then you can show why, these types of gloves and so on. But that's a great point. Yeah, I'm anything that fails is I always keep it. I'm like a pack rat for failed components. It's so yeah, definitely great point. Keep what good and what bad is.
Failed components are a key learning opportunity.
Yeah, totally.
So I don't have any other Q&As unless people have some. We could put them right in. I do want to interject and say we were able to begin the recording of this directly at 1 p.m. So when you signed up, you will get a notification that this recording has been completed. So you can you'll receive the recording. You can share it with whoever else you want. It will also be up on our YouTube page, and we'll share it on our Facebook social medias as well. Oh, hold it. I've got a new post. David Morris says, I'm in the tool room. Do you have suggested tools for working on EV cars?
We do, actually. There is, your high voltage installation tools, but we are going to do, actually, it was one of my other modules I actually had. But big thing is make sure you have your insulated tools, especially with students, because, they're using ratchets for the first time, the extensions. They might be just doing a nickel metal hydride battery in a Prius that you have there for demonstration, and they wind up touching something. They're not supposed to. It's good to have those insulated tools. I can't stress tools, gloves, your PPE, your glasses, and so on.
I think the three very basic things that every school should have starting, and I'm saying the baseline that you need would be a set of gloves, and that's per individual or for the instructor, whoever's going to be doing the work, whether it's the students. Set of gloves that are of the right voltage value and up to date, not expired, and the right type. A set of tools, so insulated tools. You'll see those sets of, and then a 1587 or equivalent insulation tester. Those are the three things that you need to get started working on a high voltage vehicle. Gloves, basic little toolkit of the insulated tools, and an insulation tester. Because with those three, now you could walk up to, as an instructor with some students, you could walk up to a Tesla, a Chevy Bolt, a Nissan Leaf, a Toyota hybrid, whatever, depowered vehicle, go in, open something up, measure real voltage, and then disconnect something. So.
Yeah, and the one last thing too is that if you're looking for a meter, make sure it's at least a class 3 meter. When you're purchasing, it can be any kind of meter, but as long as it's class 3, make sure your cables are class 3 as well. And also making sure any of your adapters are class 3. So all 3 components are there. I have been using this meter for a very long time. It's a class 3. It's a 233 Fluke. What I really like with it is it can disconnect from the actual meter. So I can actually have the body of the tool in back to the vehicle where the high voltage contactors are, have it all set up, go to the front of the vehicle or with the students, have my little meter in front of me, and then basically turn the vehicle on. And everybody's away from the high voltage in that point. So it's a great way of demonstrating high voltage. It is magnetized on the back as well too, but tools like that you can really help with teaching, especially keeping safe. You could be even in the front of the classroom, and so somebody turns on the vehicle and you could be there and they can pass it around, whatnot. So kind of neat stuff. It's Bluetooth technology, so it's quite a good range as well.
Right.
And the Q&A is clear. So with no more questions, we can basically wrap this up. We will re-adjourn another webinar in the new year. Do we have that date selected yet, Nathan? I don't think we do yet.
Yeah, we do. We have the next, I think, 4 dates selected. So the next one is on January 10th, Wednesday the 10th, same time, same place. And please, like I mentioned earlier, please submit any comments, suggestions. You can email to Jimmy or info@Consulab or to any of us of which areas you'd like to hear more information about, whether it's about gloves, meters, isolation testing, high voltage interlock, doing specific procedures, doing some procedures with products. We will next time go through the Ohm's Law Trainer, and I'll build up the circuit for you and show you how you build a very entry-level basic circuit that we can demonstrate to have the students do and have them learn how the interlock circuits work, because we didn't even get a chance to talk about that today. It's very interesting stuff. Great for teaching. So
we have 2 more questions now. So one, again, from my friend Tony in Alaska, is Class 3 the same as Cat 3?
Class 3, no, it's a different voltage value. So Cat 3 and Class 3 run different voltage values. So within your Cat rating that you have, like we always say, I'll go with a Cat 2, 600 volts, Cat 3, so on. I just gotta look at myself. Cat 2, 600, Cat 3's 1000. So, dual meters, most meters are capable of a Cat 3 anyways. But what was the question? Was the type?
Is Class 3 the same as Cat 3?
Yeah, are we just misspoken when we say Class 3 instead of Cat 3?
Yes, I apologize. Yeah, I may have said
I think we're
Class
just
3. Yeah.
I think we meant to say Cat. I think it is a Cat certification, so you want a CAT, and I can't remember what the Cat stands for, but I'm sure
they weren't sure.
It's not feline.
Canadians just called it something different. It's probably
no, that's right. Yeah, sorry about that.
Another question is, do you have suggestions about companies to recertify gloves and hooks?
I get that question all the time. And that's great to mention about the hooks too, because they actually have a service procedure as well, cleaning them and getting them recertified. But what I usually do is I tell people to check one with the parts suppliers. That's a great way where you may be accessing the gloves, let them deal with them, or a local electrical supply company. Any of those companies, they are sending out gloves to linesmen. I know that even some power companies will even do them, but there's a couple of companies here in Canada, I think they're in Ontario and Quebec, they do certification, but I always try and push it off to the people that sell you the gloves, because at the same time, that's part of the service. They're selling the product, they should be able to help you keep them certified, or give you at least the ability to find out where you have to send them and so on.
All right. Now the Q is clear.
Okay, that's great.
Wonderful.
Great questions. Thank you.
Yeah.
All right. Well, I think that is the conclusion then. We want to wish everybody a wonderful holiday, and we appreciate your attendance at this one and any of the previous ones. And hopefully we will see you on January 10th at our next one.
Awesome. Sounds great. Have a great holiday, people. Thank you.
Thanks for your time, Nathan. Much appreciated.
Thank you.